All right, we're back for example 2, and we're talking about rhombuses. So a rhombus is a quadrilateral that has 4 congruent sides. Okay, so this is the definition of a rhombus. So it has, here's a quadrilateral, it has 4 congruent sides. They're all the same. Okay, that's what makes it a rhombus. So let's talk about different properties of rhombuses. The first one, theorem 643, states that if a quadrilateral is a rhombus, so if a quadrilateral is a rhombus, then it is a parallelogram. Okay, so if it's a rhombus, then it's a parallelogram. This is very similar to the one that was like, if it's a rectangle, then it's a parallelogram, right? So why this is useful is that if the problem states that it is a rhombus, then you can say, well, if it's a rhombus, then it's a parallelogram. Then all of the it kind of unlocks the treasure box, right? So you have the opposite sides are congruent. You have the opposite angles are congruent to each other. What else do we have? We have the consecutive angles are supplementary. So this one and this one add up to 180 degrees. And then we also have that the diagonals bisect each other, right? So that's our lovely little treasure box here, okay, with, you know, jewels and just, I don't know, it's a jewel. There's lots of jewels. These are the parallelogram jewels. All right. So if it's a rhombus, then it's a parallelogram, and we unlock the treasure chest. Okay, what else? If a parallelogram is a rhombus, then its diagonals are perpendicular. Ooh, that's fun. So with the, what was it? With the, so parallelograms, the diagonals bisect each other. With a rectangle, the diagonals are congruent, and now with a rhombus, the diagonals are perpendicular. Ooh, that's going to be fun. If it's a rhombus, the diagonals are perpendicular. Like when we get to those coordinate proofs, and we're going to probably have to prove that something is a rhombus, how would you show in a coordinate proof that the diagonals are perpendicular? Right? These diagonals are perpendicular, right? That means that you'd have to find the slope of this one, and you have to find the slope of this one. And do you remember about the slopes? How you can tell they're perpendicular? There was two things. They were opposite signs, and they were reciprocals of each other. So like if the slope was 3/4, then the other one, it was positive. This one would have to be negative 4/3. And the slope of one is 3/4, and the slope of the other is negative 4/3, then you know that they're opposite sign, reciprocal, and they would be perpendicular. And so what this is saying, if the diagonals are perpendicular, then you know it's a rhombus. That is fun. Okay, on to the next one. And then it states, what's this one state? This one states that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Oh, goodness. Okay, if a parallelogram is a rhombus, so we have a parallelogram is a rhombus, then each diagonal bisects, that means cuts in half, a pair of opposite angles. Oh, wow. Okay, so the diagonals are not only perpendicular, they bisect each angle. So this diagonal bisects this angle, so that means 1 and 2 are congruent. It bisects this angle, so that means 3 and 4 are congruent. It bisects this angle, so 5 and 6 are congruent. And bisects this angle, so 7 and 8 are congruent. So if it's a rhombus, each diagonal bisects the opposite angles. Okay, perfect. Now, I shouldn't have to say this, but I'm going to. This is going to have to be a flashcard. Okay, I hope you guys are still making your flashcards. Flashcards. And I don't think I said it, but these also, for the rectangles, this should also be a flashcard. And you need to go over these so that they are fresh in your brain, because when it's fresh in your brain, it's way easier. Okay. And like a rectangle, a rhombus is a parallelogram, so you can apply the properties of parallelograms to rhombuses, which are these 4 lovely jewels right here, okay? So let's look at our first example, example 2. I'm going to cover up all this stuff, okay. TVWX. So here we have TVWX. Okay, using properties of rhombuses to find measures. TVWX. It's a rhombus. Okay, that's nice. We know that all the sides are the same just because of the definition of a rhombus. We have to find TV. We have to find this side length. How are we going to do that? We know that it's a rhombus, right? So we know that all the sides are the same just by definition of a rhombus. So if we look at the sides, we have this side and this side, right? If we kind of prove that those are equal, then we can figure out what B is, right? And then if we found out what B is, we can always substitute it back in there. And we know that all the sides are the same. So if we find one side and we figure out what it equals, then that's really going to be the same thing as TV, right? Because the sides of all rhombuses are, since it's a rhombus, they're all congruent to each other by the definition of a rhombus. And it says it's a rhombus. So yeah. Okay, so I really think that's the direction we're going to go. Let's see what we do. I'm going to say first, I'm going to give it a 0, and I'm just going to say we need to just establish that it's a rhombus. So TVWX is a rhombus. And that's just given. Okay? All right. And then what was this saying? This is saying WV is equal to XT. Okay, perfect, because it's a rhombus and all the sides are the same. So definition of a rhombus, and then we substitute those things in. 13b minus 9 equals 3b plus 4. Substitute, perfect. We do some subtraction property of equality, no big deal. 13b minus 3b is 10b minus 9. That cancels. We got 4 there. Okay, we're trying to isolate b, right? So what's the next thing we're going to do? Probably some add 9 to both sides, addition property of equality. We're just doing algebra here. We get 10b equals 13. Then we're going to do division property of equality. And b equals 1.3. Okay, that's what b equals. And then what do we want to do? We want to figure out what TV is. So we're going to substitute this back either here or here. What do we do? So TV is equal to XT. Okay, TV is equal to XT. All right. That's because the definition of a rhombus, right? All the sides are the same. And then, okay, so instead of XT, we're substituting 3b plus 4 in for XT. And then we're probably going to substitute again and put 1.3 in there, that substitute. And we just do this math. 3 times 1.3 is going to be, I think, maybe 3.9. And then you add 4 to it and you get 7.9. So that's how we got TV. Simplify. All right. Does that make sense? Do you guys see that? Do you get it? Yeah, so that's pretty much how you set it up. Looks good. Okay, let's look at 2b. It says for 2b, we're still using the same figure, okay? For 2b, it says that TVWX is a rhombus, and we need to find the measure of VTZ. So what is VTZ? VTZ. Okay, so we are finding this angle here. We're finding this angle right here. This angle. Okay. This angle here. Now, how are we going to figure that out? What do we know? Okay, so let's look at this figure. We want to figure out that angle. Okay, so what I know, right? I know that if the parallelogram is a rhombus, then the diagonal bisects each pair of opposite angles. So that means that this diagonal bisects, this is 3 and 4 the same. So I know that this angle and this angle are the same, right? So there is nothing for this angle. But since I know this one and this one are the same, and there's something for this angle, right? Okay, so that's something I know, okay? But I need to figure out what A is. And that doesn't help me. But what else? It says 14a plus 20, and then it gives that angle. Now, why do you think that would be helpful? Without looking, why do you think that would be helpful? Well, what do we know? Okay, we know that if it's a rhombus, then the diagonals are perpendicular, right? And if they're perpendicular, it means they meet at 90 degrees. So that is really our equation. We know that this is 90 degrees. So we know that this angle is equal to 90. So that's our equation. 14a plus 20 equals 90. Then we can use that, figure out what a is. Then we substitute it in there. Then we figure out what that angle is. And that angle is the same as this one. So whew, that's how we determine what that angle is. Okay, does that make sense? Do you guys got it? So because if a parallelogram is a rhombus, its diagonals are perpendicular, then we know that the diagonals being perpendicular equal 90 degrees. We can set this equal to 90, figure out what a is, substitute a in there, figure out that angle is, and we know that those two are the same because if it's a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Bisects means it cuts in half, which means they are the same. Whew. Okay, let's go for it and appreciate. We're appreciating this problem. Okay, so first, what do we have? First, what is not here is that the sucker is a rhombus. It needs to say that it's a rhombus. So we need to say 0. I'm going to put it up here because I don't have any room. TVWX is a rhombus. TVWX is a rhombus. And that is given. Okay, now from there, we can say that the measure of this angle right here, VZT, this one, is equal to 90 degrees because if it's a rhombus, the diagonals are perpendicular. Okay, then it would also probably be good to give what that given information is. Measure of angle VZDT is equal to 14a plus 20, but you know. So anyway, so we're substituting that in because that's what this angle is, 14a plus 20. Equals 90, so we're substituting, and then we're just going to use algebra, right? Subtraction property of equality, 14a equals 90 minus 20 is 70, and then we got to get a by itself, so we're dividing both sides by 14, and 70 divided by 14 is 5. Perfect. So now we know what a is, okay? Now, what do we have here? Running out of room, so we're going over here, and basically this is measure of VTZ. VTZ is the one that we're trying to determine, VTZ, and this is equal to ZTX, ZTX. Okay, so we're basically just stating that these two angles, the measure of these are equal, and they're equal because if it's a rhombus, each diagonal bisects opposite angles, okay? So there we have, if it's a rhombus, each diagonal bisects opposite angles. Okay, okay. And then we're just going to substitute this value in. So ZTX is 5a minus 5, right? So we're substituting that in. And then we're also substituting what a is. So a is equal to 5, so we're substituting 5 in for a. And we get 5 times 5, which is 25. 25 minus 5 is 20. So that is what the measure of VTZ is. It's equal to 20. You know, substitute, simplify. Boom, we did it. All right, so that is appreciating. And I just want to have this as a record so you can use this as a reference. All right, let's go ahead and look at this next problem here. Check it out, example 2a. Okay, and we're using this here. And I want you to go ahead and try 2a on your own. So here's my friend the pause dragon reminding me to pause your device. Go ahead and work out 2a only. And when you get done, press play and we'll talk about it. All right, see you in a bit. Okay, we are back. What do we have? CD, FG is a rhombus, and we need to find CD. Okay. So looking at this, I know it's a rhombus. I know that all I have are these side lengths, right? I know that it's a rhombus. What else do we know? I know it's a rhombus, 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 rhombus. It's a rhombus, so all the sides are the same. Okay, if I'm able to figure out what these two sides are the same, so I can set them equal to each other, right? And then I'll have my equation. And then whatever I find out what A is, then I can substitute it back in. I'd probably substitute it back in here, figure out what CG is. And then I know that CG and CD are the same because definition of rhombus. And then I'd figure out what CD is. Okay, sounds good? Let's do it. All right, so 0 is just going to be that CDFG is a rhombus. And you know what? I'm actually going to put this stuff too. So CG is equal to 5A, and FG is equal to 3A plus 17. And all of that is given information. Given. Okay, now I'm just going to state that these two are the same. So CG is equal to GF. Or I probably should say FG. Where's my, just to keep everything the same. FG. FG, and that is just because the definition of a rhombus, all the sides are the same. And I'm going to substitute that in. So CG is 5A equals FG is 3A plus 17. Substitution. Now we're just going to do algebra, right? So subtraction, property of equality. Okay, that's subtraction, property of equality. Property of equality. This is simplifying. And then we got to get A by itself, so we're going to divide by 2 to both sides. That's division, property of equality. So we end up with A equals 17 divided by 2, what, 8.5? Yes, simplify. Okay, now we know what A is. And now I'm just going to say that CD is equal to CG. So CD is equal to CG, right? That's definition of a rhombus. Okay, then I'm going to substitute what CG is. CG is 5A. So CD equals 5A. That's just substitution. And then I'm just going to substitute again. A is equal to 8.5. Substitution again. And then I just need to figure out what that is. So 8.5 times 5. 5 times 5 is 25. 5 times 8 is 42. 1 decimal spot. So CD is equal to 42.5. And what does that simplify? So if you got that right, awesome, awesome. Okay, let's look at this next one. Okay, example 2B. It says CDFG is a rhombus. Find the measure of GCH. Okay, so we're finding the measure of this one. GCH. If the measure of GCD, oh, the whole angle is, what is that, B plus 3? And the measure of CDF, this angle is 6B minus 40. This one looks like fun. Okay, well, I'm going to give you a chance to get started on this one. Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work this one out. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did. Okay, a lot. So we have to find GCH, this angle. It tells us that GCD, the whole angle, is B plus 3. And then CDF, that whole angle, is 6B minus 40. So what I'm seeing is that, I'm just going to write, oh gosh, this is a terrible picture. I just can't look at this. This is terrible. Terrible drawing. Okay. I'll do it right here. Okay, so what I'm seeing is that this whole angle, what is this, C, D, F, G? So this is not a G, that is a G. GCD is B plus 3, and CDF is 6B minus 40. Okay, so what I do know is that because it's a rhombus, I need to find this part, right? So we know that this diagonal bisects this in half, so this is the same as this, and it's half of the whole angle. But I really need to figure out what this whole angle is. And right now I only have this information, but since it's a rhombus, I do know that it's a parallelogram, right? And so if it's a parallelogram, that these angles are consecutive angles, are supplementary. So I know this angle plus this angle equals 180 degrees. So that's going to give me my equation so I can figure out what B is. Then once I have B, substitute it in. And then basically I can figure out what this is because it's just going to be half of whatever this angle is. Okay, so I think that's the direction we're going to go. First, we need to write down the given information. So I'm going to start there. I'm going to write it up here. So CDFG is a rhombus. Okay, and then what else? We have all this given information. I'm going to say the measure of angle GCD is equal to B plus 3. That's a 3. That's a very terrible 3. I can do a better 3 than that. Oh, gosh, what is going on with me today? Okay, B plus 3. And then what else do we have? We have the measure of angle CDF is equal to 6B minus 40. And all of that is given. It's lovely given information. All right, so it's a rhombus. Since I want to use that parallelogram information, I think I need to state that this is a parallelogram. So I'm going to say that CDFG is a parallelogram because if it is a rhombus, then it is a parallelogram, right? And now I can just go in and say that these are supplementary. So I'm going to say the measure of angle GCD plus the measure of angle CDF equals 180 degrees because if it is a parallelogram, then the consecutive angles are supplementary. Nice, nice. Then we just substitute in the values, right? GCD is B plus 3, so we have B plus 3 plus measure of CD of 6B minus 40 equals 180. That's substitution. And then guess what? It's a whole lot of algebra. Okay, so combine like terms there. B plus 6B is 7B. We got 3 and a negative 40. That's going to give us negative 37. That's just simplify. And then what? We got to isolate B, so we're going to add 37 to both sides. That's some lovely addition property of equality. At cancels, we're left with 7B equals, what's that? That is 217. What a lovely number. And then, what is that, simplifying? And then we're going to do some nice division property of equality. Okay, division property of equality. And 217 divided by 7 is actually 31. Okay. So now, what do we know? We know that, what do we know? Okay, so we know what B is, right? B is equal to 31. So we can actually figure out what this is. Or what do we know? We know GCD is that, right? So we know what B is. And we need to do this, which is half. So we can say that we can just talk about the whole angle, right? GCD is equal to these two angles, like added together because of the angle addition postulate, right? So we can say that the measure of angle, the big one, GCD, is equal to this angle, GCH plus HCD. The measure of angle GCH plus the measure of angle HCD. Okay, and those are just this. So it's this angle and this angle, right? These two angles add up to the whole angle, right? And that's just the angle addition of postulate. Okay? Now, we can say, what can we say? We can actually say that these two angles are the same because, right, these two angles are the same because if it's a rhombus, the diagonal bisects the opposite angles. So let's go ahead and say that the measure of angle GCH is equal to the measure of angle HCD because if it is a rhombus, then each diagonal bisects opposite angles. So because of that, we can substitute this in for this. Okay, we can substitute that in for that. And so we would end up with measure of angle GCD equals measure of angle GCH plus the measure of angle GCH. Okay, because basically those are the same, and that's just substitution. Now we can simplify that. And we get 2 measure of angle GCH because GCH plus GCH is just 2 of them. Okay, that's simplify. And then now I think would be a lovely time to put in what GCD is, right? What is GCD? GCD is B plus 3. So we can substitute that in. B plus 3 equals 2 measure of angle GCH. And then we can, that's substitution. Then we can substitute 31 in for B. So 31 plus 3. Okay. That's substitution. 31 plus 3 is 34. Right, that's just simplify. 15. And then I think I'm going to take this, I'm going to have to go on the road. Let's go over here. Maybe I'll change my color. And we just need to, I'm going to write it, 34 equals 2 measure GCH. And then we just need to isolate this, so we're going to divide both sides by 2. What's that going to give us? 17, I think? Yeah, 17 equals measure of angle GCH. So this is division, property of equality. This is simplifying. And then we just need to use that symmetric property of equality. Just flip-flop it. GCH equals 17. Symmetric property of equality. And there we have it. There's our answer. So if you got all that right, yoga-denki-mashita, you did a wonderful job. If not, go ahead and change your work so it looks like mine, and I will see you in a little bit for example 3.